In this video, we're going to talk about transformations of functions. We're going to start the video by talking about translating the graph of a function, which basically that means if you have something that's being added or subtracted with the x, or added or subtracted outside of the x, then that's translating. It'll be moving it up and down and left and right. Okay, so let's talk about that first. Let's look at this first one. It says we have the graph of f of x shown below. Translate to get f of x plus 2. Okay, so when you have something like this that's outside of the function here, it's adding 2 to the function. All that's doing is adding 2 to your y values, right? Instead of y being equal to f of x, y is now going to be equal to f of x plus 2. So it increases all of your y values by 2, right? So the entire graph gets shifted up by 2. Okay, so if you create a few points here, so we've got 4, 0. That point will turn into 4, 2. Okay, and then you could try some other one, like this one down here would be shifted up 2, and this one down here would be shifted up 2. And then you could draw a graph. Okay, so that is what the graph of f of x plus 2 looks like. It shifted it up by 2. Okay, next one, we've got g of x shown below. What happens if you find g of x minus 5? What does this minus 5 do since it's on the inside? Well, on the inside, it's going to move left and right. Unlike the outside over here, which moves up and down, up being positive and down being negative, here we move left and right, and the rules are reversed. So you might think, oh, minus 5, that means I move to the left, but it's actually the opposite of that. When it's inside, you move the opposite direction of the sign. So since this says g of x minus 5, we're going to actually shift this thing positive 5, in the positive 5 direction on the x-axis. So this 0, 0 gets shifted over to 5, 0. Okay, and we can shift a few other points if we can find them. It looks like this point was negative 2, negative 1. So just move that over 1, 2, 3, 4, 5. Okay, and let's see, this point was 2, negative 1. So 1, 2, 3, 4, 5. Okay, and that gives us a new parabola. It doesn't have to be exact. If you're doing this on some sort of graphing device, you should only have to type in your points to get it to give you a perfect parabola that's been shifted to the right by 5 units. Okay, next one. Looks like we've got two different translations on this one. Y is equal to x squared becomes y is equal to x plus 2 squared plus 1. So this makes it move left 2, and this plus 1, I wish it would have been up here like this. Let's just write it that way. So x squared plus 2, or x plus 2 squared plus 1. The plus 1 makes you go up, up 2. Okay, or up 1. Man, okay, up 1. So we want to go left 2 and up 1. So let's take this point, left 2, up 1. There's my new center, my new vertex of this y is equal to x squared quadratic. Okay, looks like there's a point here at 1, 1. So if I move it left 2 and up 1, it goes here. Here's a point at negative 1, 1. So up, or left 2, up 1. Okay, and then we have our parabola. Okay, so it's been shifted left 2 and up 1. Okay, let's look at these. So below is the graph of y is equal to 3 times the absolute value of x. Now translate to get 3 times x minus 2, which is on the inside with the x, and then minus 1. So since this number's on the inside with the x, that's going to go the opposite direction. So let me write this down here because it's not enough room. Y is equal to 3 times x minus 2, absolute value, minus 1. Okay, so this is going to make it go right 2, and this is going to make it go down 1. Okay, so I go right 2 and then down 1. That's from this middle point, right 2, down 1. Where's another point? Looks like this is a point right here at 1, 3. So I go right 2, down 1. Okay, here's another point at negative 1, 3. So right 2, down 1. Okay, and this is a V-shaped graph because it's an absolute value. And it should look the same as the original graph, except shifted over 2 to the right and 1 down. Okay, let's look at this one. We've got the graph of square root of x. So we've got this plus 1, which makes it move left 1, and this minus 4, which makes it move down 4. Okay, so left 1, down 4. Okay, where's another point? At 4, 2. 4, 2, we go left, left 1, and down 4. 1, 2, 3, 4. And then we make our little half of a sideways parabola. Okay, last one. Below is the graph of y is equal to x cubed. We want to move to the, this is going to make it move to the right by 3. Let me write it again down here. X minus 3 cubed plus 4. Okay, so right 3, up 4. Okay, so let's take this center point and go right 3, 1, 2, 3, and up 4. 1, 2, 3, 4. That's my new center. Okay, what's another nice point? Looks like 1, 1 is there. So right 3 from here, 1, 2, 3, and up 4, 1, 2, 3, 4. And here's negative 1 is a point on the graph. So right 3, 1, 2, 3, and up 4, 1, 2, 3, 4. Okay, so the graph is going to look like this. It's going to level out and then keep going.